Hello, Honors Algebra. Mr. Lawrence here with a surprise flipped lesson. I know some of you are becoming very conscientious students and really caring about your grades, and I was willing to bet money that some of you, when you're boredom this week, because you probably have times when you weren't sure what to do with yourself, would go and check out the videos and try to stay up because you know you have your final exam coming up. So I decided to go ahead and post a Chapter 10 review just to help you stay sharp. By the way, overall the scores were pretty good. A couple people had a hard time, but overall doing a nice job. So let's keep up the good work. All right, Chapter 10. First of all, it all begins with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, remember when you're using this, why do we do it? Well, the main reason is to find the zeros. What does that mean? It finds for us the places where a graph crosses the x-axis if the equation is quadratic. Okay, now remember this part here, right here, is called the discriminant. That part there tells us how many zeros. Remember that if b squared minus 4ac is greater than 0, there's two solutions, right? If that is equal to 0, there's one solution, and so that means two solutions or two zeros or two roots. If b squared minus 4ac equals 0, that means there's one solution, okay? And if b squared minus 4ac is less than 0, in other words negative, there are no solutions or no roots. All that means is that the graph does not cross the x-axis, okay? So right off the bat, we check our discriminant. That tells us how many solutions we're going to have. The whole formula finds those zeros or solutions, finds out where they are. Now look, don't miss the subtlety here. If we're finding zeros, points on the x-axis, doesn't the y-coordinate have to be 0? We don't have to go looking for a y-coordinate. We know it's 0. That's what we mean when we say we're finding the zeros. Of course, that's only true for finding the roots or the solutions or the zeros. That does not apply to the vertex. Now, speaking of the vertex, this part of the formula right here, okay, that gets us the x-coordinate of the vertex, right? That gets us the x-coordinate of the vertex. Usually the y-coordinate is not 0. We'll have to go look for it. There is a time when we might know, oh yeah, there's only one solution. The vertex is on the x-axis. And if that's the case, then, oops, we don't have to go and look for it. This is getting very interesting. There we go. Okay, there's a little cross out there that's unintentional. So this formula is very, very powerful. Let's look at a real basic one here. Let's say we have an equation like this, y equals x squared minus 4. Now we're going to do a whole bunch of things with this one. We're going to find the zeros. 2, we're going to, I apologize for the sloppy writing. I'm doing this on the airliner at home, and so I'm practicing. But as I get better at it, I should be able to write more legibly. Oops. We're going to find the zeros. We're going to find the vertex, right? Okay, and we're going to graph it. In the graph, we'll be able to determine if it opens up or down. Some of you should already know it opens upward. But there's a couple of resources I want to point out to you. I've been mentioning in the class, but a lot of you don't use them. One is a free online graphing calculator. It's right there. Okay. All I did was type in a search, free online graphing calculator, found it, and I can type in any equation right here. Like if I want to get ahead of myself right now, And let's see here. Oh, it looks like I might be in ink mode. So let me close that. And right here, okay, get my caps lock off. I'm going to do x squared, and I'm going to do minus 4. The calculator will graph it for me. And there it is. Now I'm going to do the vertex and the zeros and all that by hand, but you've got this wonderful online tool at your disposal. If you can't afford a graphing calculator, here's one for you. Use it. Use it to help you do better. All right? Build a better understanding. Now, I also have this other one over here. Let me get my recording box out of the way. And this is a quadratic equation solver. You know what I did? I typed in quadratic equation solver. Now it shows part of the graph for this equation, but I'm going to change this equation. I know that A is 1. I know that B is 0 in this case, x squared minus 4, and then C is negative 4. And look at that, it'll even give me the graph. Okay, now it's not showing me the whole graph because I'm solving, but it tells me the solution is negative 2 and positive 2. Now I'm going to go through and do the work, but again, it's there. And look down here. X squared minus 4 equals 0. The roots are negative 2 and 2. Those are the solutions or the zeros. It tells you the value of the discriminant. It tells you where the vertex is. It tells you what it looks like in factored form. And it tells you if you add the roots together and the product of the roots. Okay? That's a little bit extra from what we do. But the point is, guys, you have tools available to you. I would have killed for tools like this when I was your age. Taking Algebra 1 in 8th grade, but you guys have them and they're free. For me, this kind of stuff didn't exist. And when it first came out, it was too expensive. All right, so I'm going to take this equation now. It was y equaled x squared minus 4. And the first thing I'm going to do is identify A, B, and C. Okay. Then I'm going to use the discriminant. So the first thing I did was find A, B, and C. I'm going to do B squared minus 4AC. I know that B squared is 0. I've got a minus 4 times a 1 times a negative 4. And notice when I substitute in, I use my parentheses. 0 squared is 0. Negative 4 times 1 times negative 4. Notice I said the word negative twice in a multiplication problem, which means I'm going to get 0 and a positive. 4 times 1 times 4 is 16. That equals 16. All right, so my discriminant is 16. If you remember from the last problem, the calculator told us, or the solver told us 16. So now I'm going to go into the quadratic formula, but I'm not going to write down b squared minus 4ac. I'm just going to put 16 in its place. It's okay because I've done all the work right here, right? So I'm going to do x equals the negative of b is 0 plus or minus the square root of 16. The whole thing is over 2 times 1. All right, x is going to equal plus or minus 4 over 2, which means x will equal 2 or negative 2. And that is what the online thing got for us. I need some graph paper here. Okay, I know that one of my zeros is at 2. The other one is at negative 2. All right, let me mark. There's a y, and there's an x. Okay, I'm not ready to graph yet because I don't have my vertex. Well, I'm going to use this part right here, which will simplify to 0 over 2. That'll be the x-coordinate of the vertex. X equals 0 divided by 2. Well, that's just plain old 0. So in a t-table, I'm going to plug in 0, and I plug it into the equation y equals x squared minus 4. 0 squared is 0, minus 4 is negative 4, and there we go. So my vertex is at 0, 1, 2, 3, 4. Okay, and now I'm ready to draw my graph. I'll draw it in blue. And And it's not going to be a beautiful one because it's really hard to do this with the eyeliner. Listen to me, the airliner, but basically something like that. Okay, let me see, how am I doing on time? All right, 10 minutes. All right, let's do another example so you have practice here. Okay, let's take this equation. I'm going to make one that's a little bit ugly. Y equals x. Let's go 2x squared plus 9x minus 3. Yeah, there's no way that can be factored. The roots should be pretty ugly. All right, I'm going to go A, B, and C. First thing I'm going to do, I got 2, I got 9, I got negative 3. Now I'm going to find the discriminant. So B squared minus 4 times A times C, that's 81. A negative times a negative is a positive. 6 times 3 is 18. So my discriminant ends up being 99, right? I know the square root of 99 is going to be pretty darn close to 10 because the square root of 100 is 10. But I know I'm going to get two solutions. I'm going to go to negative b plus or minus the square root b squared minus 4ac. The whole thing is over 2a. So that will look like this. Negative 9 plus or minus the square root of 99. And then I will divide by 4. How did I get 4? 2 times 2 is 4. Okay, now it's okay to go to the calculator and get some values here, approximate values. All right, let me see here. I'm actually going to do it on here. You guys should be going to a calculator. Hold on one second. Okay, A is 2, B is 9, and C is negative 3. Okay, there we go. Now, if you did the math on your calculator, you should have done negative 9 plus or minus the square root of 99. Got that answer and then divided by 4. Okay, and then do negative 9 minus the square root of 99. Get that answer and then divide by 4. And when you did that, you should come up with x is approximately to 4.81, or, oh, I like this. I don't know how I did it, but I like it. X equals, oh, is approximately equal to, 0.31. Yeah. All right, there we go. So I've got those. I can plot those on my calculator. Oh, I know why. I'm going to lose them here, aren't I? Okay, it was 4.81, and then x approximately equal to 0.31. All right, so I'm going to go ahead and minimize that. Get a sheet of graph paper out here. Shoop. Okay, I got to get a little more room here to work. Put my zeros in, which are right there, 0.31, so just a little bit less than a third. And I'm going to label it, of course, 0.31, and then a 0 for the y-coordinate. Negative 1, 2, 3, 4, 5, right there. And that's going to be negative 4.81, and then 0. Got to find the vertex. Well, I do negative a over 2b, but if I'm working smart, not hard, I notice that the x-coordinate of my vertex is right here. Right here, negative 9/4, or negative 2 1/4. So I know the x-coordinate of the vertex equals that. And then I can go to my t-table, and I'm plugging into the original equation, this equation right here. And at this point, I'm going to plug it in to be careful, but I'm going to use my calculator. I have 2 times negative 2.25 squared plus 9 times negative 2.25 minus 3. This is a situation where fractions might suit me better. I'm going to do 2 times 9/4 negative squared plus 9 times negative 9/4 minus 3. And they're not going to come out as pretty as I thought. I saw something. So that's okay. I'll just go to the calculator with this one right here. All right, so let me get my calculator going here. Hold on one second. I don't know if a lot of you realize this. Google is a calculator. Notice in the search window in Google, I typed 5 plus 3, hit enter, and it gave me the answer 8. Okay, Google is a calculator. All right, so let me see if I can bring this other thing up so I can see the problem I need to do. Okay, there we go. So I am going to enter negative 2 parenthesis. Oop, it shouldn't be negative 2, excuse me. Parenthesis, oops, negative 2.25. And then I think I can do this, and it'll square it. And notice it's doing the work down below. And then I need to add 9 times the quantity of negative 2.25. And then I want to subtract 3. And look at that. It did it all for me. I got the answer of negative 13 and 1/8. 0.125 is 1/8. I know that just from experience, okay? So negative 13 and 1/8. So in that t-table I was talking about, right about here, I should get negative 13 and 1/8, or 0.125. So let me see, negative 2 1/4, 1, 2 1/4, so that's 10, 11, 12, 13. It's going to be right about there. And since it's hard for the reader to know what point I'm intending because it's off the graph, I'm going to put it in like that. Now, by the way, the axis of symmetry is going to go right through that, right? Right about there. And it's off just a smidgen, but that's okay. I can move it over. And now I'm going to attempt, again, to draw my parabola. And this is tough to do with the airliner. But I imagine in a couple years, if I've been doing this long enough, I'll get really good at it. Okay, there you go. There's a very poorly drawn looking parabola. All right, I know this video is going a little bit long, but there's one more type of problem I want to do for you. A lot of you seem to have trouble with the football type problem. Okay, the football type problem. We're going to kick a football through a goalpost with a certain velocity, right? And we need to know if it's going to go high enough that it'll have a chance to go through the goalpost. So we're going to kick it, it's going to go. Will it work? Well, let's say the goalpost this time, goal, there we go. Let's make the goal post, the crossbar of the goal post is going to be 15 feet high. Okay. We're going to use our initial velocity is going to be, say, 20 feet per second. Can the ball go through the goalpost? Now, the equation we need is this one, I'm using a lot lately, h equals negative 16 t squared plus v sub o t plus or minus v sub o t plus s. Okay, now let's just fill in what we know. All right, well, obviously, negative 16 t squared is going to be in the formula. We know V sub O is positive. Why? Because the ball's being kicked upward. And V sub O is 20. Okay. Now the real question is, what are S and H? Some of you are thinking you should put the 15 in. I disagree. I don't think you should. I think S stands for the starting height. You're starting from the ground. H stands for the ending height. The ball will end on the ground. So we're not going to plug anything in. In fact, if you just want to use this and then find a vertex with that, that's supposed to be a T on the end there. Let me see if I can do that. Okay, erase it, redraw my 0, put the T there. Now I'm just going to find the vertex. So I'm going to go x equals negative b over 2a. I'm not going to waste my time using the whole quadratic formula because the question does not say when will the ball hit the ground again. So I'm going to put negative 20 over 2 times negative 16, and that'll be the same as 20 over 32. And I'm going to simplify that. I know 4 is going to go into those. It's going to go in 25 times. It's going to go into 32, 8 times. So the ball will reach its maximum height at 5/8 of a second. Yeah. Now I have to figure out how high that's going to be. So I'm going to take that 5/8. If I want, I can convert that to a decimal. And I'm going to stick it into this equation, negative 16. Okay, it'd be 0.625, 5/8 plus 20 times 0.625. Okay, I'm going to go back to Google now. Ooh, where did my Google go? There it is. All right, let me minimize. Oops, I must be in draw mode. Let me minimize this and see if I can't. Okay, so now I'm going to get rid of all that. Go with negative 16. Start a quantity. What was it? 0.6. Oops. 0.625. I'll get it right eventually. 625. Close that quantity. And I'm going to square it. Plus 20 times 0.625. I'm going to close it and hit enter. And look, the ball is only going to go 6.25 feet in the air. So, I have no airliner. It's not responding. Okay, so I got the ball is only going to go 0.625 feet in the air. And so the answer would be no, it will not cross the goalpost or the crossbar. Okay, that's enough for this time. You can watch this, pay attention to it, study it a little bit, and maybe we can talk about it when we get back to school that Tuesday. All right, Mr. Lawrence signing off. I hope you enjoyed the rest of your break. Bye-bye.